Okay, welcome early valiant Barracuda dudes and dudettes. We're doing this for Mike, I think that's his name. He's having some problems with his uh, fuel, gas, and temp gauges. Okay, 64 and below, and various 60s and 70s. Not many though. Use an internal voltage regulator in the fuel. So we're going to set up a little bit of a bench test here and kind of show folks how it actually all works. So what we have here, and hopefully the video will, this is on a tripod. So right now we have power, we're just above half. This gauge is probably about done. It's been in numerous videos. We did one, I think, last winter maybe. Let's see if we're looking. Okay, great. So if you have an old early Valiant Barracuda, you obviously have fuel problems at one time or another. So everybody has a spare fuel sender. Now, as you can see, I think, and now we're going back up. So we moved it a little bit. So don't pay attention too much on how that gauge is sitting. So this is a stock repo fuel sender. They're horrible. They're not very linear at all. This box is horrible, but this is all we have, right? So some things to remember here, okay? And we're gonna bring the camera down a little bit here. Maybe we're not. We don't wanna fall over here. So the big thing here. Let me get this locked down for you guys. Maybe that'll hold. Okay, great. So in here, fuel sender is where your regulator is. Now this modification, which some folks have just taken the stock little silver box and jumpered everything out just like this is. You can make your own for about 10 bucks or so. And we can talk about that more on an actual video, actual post, not right now. So in a nutshell, and we'll kind of bring the meter up here. So we got our meter, we've got 12 volts, digital meter. So, and I'm not gonna keep on moving the camera around. So this 12 volts DC, that's your input, okay, this pin here. The meter showing 13.9, which is what your alternator should be putting out, more or less. So that's good. This pin here, this is your sender wire that goes to the fuel sender, okay? This is your pulsating 5 volts DC when you use the stock voltage limiter. This now is a steady 4.79, so this guy here is doing a pretty good job. Granted, this IC as well has been put through the ringer. I've done some really nasty stuff to it, and it's probably on its last leg as well. However, proper heat sinking and just normal operations, this will last forever, but I've put way too much voltage in it, under voltage, not a proper heat sink, all types of different things to make to see what the limitations are of these items. So to do a bench test, even if it's inside your car still, there are some things that have to happen, otherwise things don't work. As a for instance, so this is the ground wire for the limiter, so that needs to be grounded well, so that is there. And yeah, look at that, we can get just about everything in now. You need to have a good ground from your sender to your fuel, to your cluster gauge, however you want to do it. But everything should have a fairly centralized ground. And then obviously the wire that runs to the from the sender to the cluster. multiple disconnects are in the car. You can have corrosion buildup. Green corrosion causes high resistance. High resistance causes false readings. So, like I said earlier, we have 12 volts DC here, 13.9. 4.74 here, awesome. And then on the sender right now we have 355 and we're empty. And when we go full, we have 1.8 something. That's moving around. 1.8. So 1.8 for total full. Okay. And then we have 3.69, 3.7 for total empty. Now that's in voltage, right? So just doing some math. So we have 4.7 here. Okay. High resistance at empty, low resistance at, I'm sorry, opposite way. High resistance at full, which means we have a lower voltage drop. High resistance at empty, so now we have a 3.74, yeah. So now what happens when we do things like, I wish I could show you guys the meter. So right now we're full. The gauge is at full. I think you guys can see that. Yeah, just about. Move that over a little bit. Oh, good. So we're at full here. Now what happens when the ground is removed from the fuel sender? Let's say the tank is not grounded properly. There is supposed to be a clip that goes from the fuel line metal part of the spout here to the actual metal lines. Clip about that long. So we remove this, okay, and now we've gone to full max, which means there's no voltage. Okay, and then same thing if we were to remove our ground from our power supply, right? Okay, so now we have nothing. So something else to look at as well. Make sure all your grounds are good. This is for the meter. And if we remove the ground for this as well, right? This is your voltage limiter. So that metal box, if that is not grounded correctly, then there's no voltage over here. All right. Some other things now. Okay, so we're going to go and flip this guy over. Hopefully nothing pops off. And we're moving up. Now there is a quick and dirty way you can check to see if your gauge is good. It's not recommended, so it's falling back down. We remove the lead from the fuel center, but if you ground your fuel center, it'll peg to max very, very fast, because now we're outside of the limits of the fuel gauge. The sender, I think, is between 15 and 27 ohms, something like that, for the resistance here. So when we give it full resistance, which is what? 0, right? No ohms at all. When we short that out, we're putting too much of a load on the gauge and you'll burn it out. So if it sweeps up and moves at all, just stop, because you know that the wiring is good, at least inside the fuel gauge. You know it's good. Then you have a problem maybe with your fuel sending wire. When you do this mod, and we'll do this real quick. When you do this mod on any internal voltage regulator, you have to do a few things to this. One is you must remove the power from the fuel gauge itself, because if you're still putting power, and you can kind of see there's I put some heat shrink tubing on there. What this does for you is if you don't isolate this post, this 12 volt DC post coming in, it will still energize the internal voltage regulator. I hope that makes sense, and let me show you the easiest way to do this. The easiest way to do this, remove the actual pin from that round connector, just remove that and make that pin go right to the voltage regulator, the new one. Remove that entirely. And then now you have no problem understanding if it's your gauge or the regulator. So right now we are not using the regulator at all inside this fuel sender. There is no way at all that could be bad. The gauge could still be bad, and in another video we'll go over how to adjust those. Yeah, this poor guy he's seen better days. It's smoked a few times on me. Just seeing how long if I were to ground the sender as it sweeps up and pegs, but she's still going. But she may stop there. Probably done. But hopefully that makes sense to everybody that this is your 12 volt input for the gauge, stock wise, right? So you really want to eliminate this all together. The new voltage limiter, okay, just kind of think of this as the input from the big round plug, right? That's your 12 volts, goes in there. The output comes out. One goes to the ground. One goes to the input for the 5 volts that runs the gauge and that runs the temperature. It just so happens that this is the one you go to. This is your temperature gauge, but these two are connected. I didn't talk about that earlier. Hopefully everyone can understand that these two are connected, gas, fuel. So now your temperature gauge will also work much better as well. And then any good ground. This has to get grounded. This should get grounded as well. That way there's no real issues, but that stud is the culprit. I've seen folks take it out, cut it off, and then stick it back in there. You can do that as well, just so that it doesn't touch anything if you're going to keep on using this. But this is any 12 volts. You don't have to actually use that pin if you wanted to wire from somewhere else. Tap off the cigarette lighter is a good one. The radio is a good one. Anything that has, sorry, not the cigarette lighter, because typically those are straight voltage. At least it is on my 64. Anything that has a switch 12 volts, you use this power here, and you'll be just fine. And let's see if she's kept climbing. Nah, she's toast. So we'll need to get another gauge at some point. We have a few. So this goes from 60 to 64. 65 they had a push in. 66 I believe was a push in and up. However, there are a few. My friend 72, 71. Dart Sport with the tachometer and all that stuff, all the gauges. His is an internal fuel gauge as well, and he did this mod. And now he has great success. So hopefully that kind of explains or makes it clear as mud, or if you have any more questions we can go over that, but this kind of is the basis for how all this works. Is you have to take 12 volts and somehow make it 5 volts for the gauges to work, in a nutshell. These are horrible, remember that. These are not. So there's linear and non-linear, right? Linear means that you turn a light switch on, and anywhere between, we'll say 105 to 115 volts, that light's going to work. Non-linear, which this is, I know it's backwards, right? But this is non-linearing sweep, which means Anywhere you go is a certain voltage. It has to be correct. I mean, these are horrible. These suck. I wonder if maybe going right to here would help. I doubt it. It's all together, but it all sucks. It's all junk. And then once again, just going over the actual pieces of the system. Fuel gauge has to have a good ground, period. Has to have a good ground. Don't think that just because your tank has the strap and all that kind of stuff, it has to have a good ground somewhere coming off of your fuel sending outlet. You have to have a good wire coming from the actual sender to the gauge cluster, and there's only one disconnect, I believe, maybe two. It's up in the left kick panel right there, green all the time. And then we'll kind of go over this again. Let's see if she moves. Yeah, she's going again. And then once again, if you take your sender wire, right, the yellow wire that we had on there before, and if you ground it, it should start moving really, really fast. And maybe this gauge is good. The sender has been put through, not the sender, the voltage limiter has been put through hell as well. This may be time to get changed as well. And just so you can see, so it's probably 50 degrees in here, and this is what, 68, 75, 79. It's been as high as 86, and it's only been running for a few minutes, right? So they do get hot. You do need to use a good heat sink. The solid state limiter that RM Specialties and the other ones sell are great as well. I just don't know how much actual amperage they put out. I don't think they put out enough. 4, 5, 4, 6. So that's not bad. But anyway, so that's kind of it in a nutshell, Michael. I hope, and for everybody else, I hope that kind of helps you guys see how all this works, and let me know if we need any more questions or any more show us and tells, and we'll see you next time.